In this video, we're going to discuss surface normals. Normals are special vectors or lines with a particular direction that are carried at the corners of each face and point perpendicular to the face. And they're used by Maya and other 3D programs to determine whether a surface is smoothly shaded or has hard shading. And hard shading is also called faceting. In fact, here's an example model that does have faceting. If you look, for instance, at the center of this pedestal, you can see a definite transition between each face. You can see where the edges are because the shading jumps from light to dark and darker and so on. If you want to open up this file, there's a file called pedestal.mb in your Chapter 5 folder of your working files directory. In any case, this is a faceted model with these hard transitions. And that's based on the normals. In other words, the normals are interpreted in such a way to give the shading this hard look. Now, normals can also be interpreted in such a way to make the transition smooth, and that's what you're used to seeing when you make a primitive like a sphere. The sphere is smoothly shaded, at least until you zoom in and look at the edges really close. For instance, if I go and create a primitive sphere right now, polygon sphere, and I'll move that model over and scale it up so we can see it. The interior of the sphere is smooth. In other words, there's no faceting in this case. The only faceting you might see is if you dolly into the edge and look really close, but the interior is smooth, whereas the pedestal on the left is faceted. So normals are referenced to determine if the surface is smooth or hard shaded. Now you don't see the normals by default, but they're there at each corner of each face. Now what you can do though is change the interpretation of those normals on a model at any given time. For instance, I can select the sphere here on the right and go up to the normals menu, which is in the polygons menu set, and choose one of 3 normal options here. There's something called soften edge, harden edge, and set normal angle. Soften will soften the model or the faces you have selected so there's a smooth transition between the faces. Harden edge will give you a hard or faster result as you would see on that left pedestal there. And set normal angle lets you choose an interpretation that lets you have a combination of soft and or hard transitions on a single surface. Let's try harden because we have the sphere selected right now. It's already soft. We can try harden edge. And then when I click off that, you'll see that now the sphere is faceted. I made the transition between every single face hard. If I want to resmooth that, I would go back up to normals and choose soften edge, which will re-soften all those normal transitions. If I click off, it's indeed soft right now. I can do the same with this pedestal. Right now it's completely fast or completely hard, so I can go up to normals and try soften edge. Now soften edge will try its best, and you'll see that it does try to make a soft transition. In other words, the normals are interpreted in such a way that Maya thinks it should be a soft transition everywhere, even though there's some steps on this pedestal. If I look more from the side, you can see, well, these are some pretty hard right angle steps. Yet when I go to a more perspective view, you can see that it still tries to make this soft, mushy transition. Because this is a more complex object, soften edge doesn't necessarily solve all the problems at once. In fact, another problem is when I look at this top part of the pedestal, it's dark right here along this bottom edge of that overhang. That's because it's trying to keep the model soft across that really big turn in the geometry. So soften edge is great for something relatively simple like a sphere, but it might have a hard time appropriately smoothing out something as complex as this pedestal. So luckily there's a third tool you can use where you can mix and match the hard and the soft elements on a single surface. And that's set normal angle. So if I go to normals, set normal angle, that's going to bring up an option box. Set normal angle, pull it back into the frame there. And there's a single option. And that option is angle. And what that means is it's going to compare sets of normals and see what the angle between them is. If the angle is less than this value, it's going to soften them. If the angle between those adjacent normals is greater than this value, it's going to harden that transition. So it's on a per face basis or per sets of faces. Really, it's comparing the normals at the corners of faces where the faces share a corner. So all these various normals overlap. So it's comparing these angles. In any case, it might be easier just to demonstrate how this works. For instance, if I go all the way up to 180 and I apply it, I get a completely soft result. everything is softened. If I go down to 0 and apply it, everything becomes faceted again. Now when it's 0, that means that, well, there's no adjacent normals that are less than 0 degrees apart. It's such a infinitely small value. None of them are exactly in the same place. So when you set angle to 0, it just automatically hardens everything, because no angle is less than 0. In other words, it can't go negative. If I go up to 180, everything becomes soft because all sets of adjacent normals have an angle between them that's less than 180 degrees. So that softens everything. So 0 is basically hardened edge, and 180 is basically softened edge. Now you can have in-between values, and this is where it gets more useful. Let's say enter a value of 60, and I try to apply it. I'm going to have a combination of hard and soft transitions. For instance, the center of the pedestal, which used to be faceted, is now smoothed out. That's nice and smooth right there. Also, the top is smoothed out. However, I still have nice hard transitions on my steps of that pedestal. And what 60 means is any pairs of adjacent normals that have an angle between them that's less than 60 degrees get smoothed out. Any pairs that have an angle greater than 60 are left hard. Now, I can imagine on the step part, because there's a hard step, if you imagine the normals coming off of this top face of the step are pointing straight up in the air. Normals on the faces that are on the side of the step are pointing straight out this way, left to right. That's a pretty big angle. You can imagine that angle is roughly 90 degrees, like this. Therefore, the 90-degree difference is bigger than 60 that have entered into angle, and therefore that transition is left hard. Whereas the faces here on the central part of the column, if you look over here on the side, you can imagine that the difference between normals coming off these faces is not that big. And remember that normals come off a face perpendicularly. In other words, they're basically coming off the face 90 degrees. If you have one face where the normal's coming off 90 degrees, and another face nearby where the normal's coming off 90 degrees, really the angle in this situation, where there's a shallow transition, would be a small angle. And I know it's a little hard to imagine now, but we're going to talk about displaying normals in a separate video. There's a way to actually display a simplified version of those normals. Now, if it's hard to imagine what's going on, just keep in mind that a large value means you have more and more of the model smoothed out. A small value means you have less and less of the model smoothed out. Now, it defaults to 30, and 30 is often good for many models. It's a bit of a magic number. But you're going to keep your hard edges on your really harsh transitions, like the steps, yet smooth out shallow transitions, like on the column of the pedestal. So let's apply 30 now. And this is a result. In this case, it's a very similar result to 60. Because really, either there's a shallow transition in faces like on here on the top, or there's a really hard transition like on these steps, or on this top edge. So if you get a model and it's either faceted or it's not as smooth as you would like, remember you can go up to normals and either apply soften edge to soften, harden edge to facet, or set normal angle to have a mixture. Now, so far I've demonstrated this on entire surfaces. You do have the option to apply those to sets of faces. That's a little trickier because you might have a really harsh transition where it goes from smooth to hard, but it's still possible to do it on sets of faces.